Variables are used for storing data during program execution. Depending on what data needs to be stored, there are several kinds of built-in data types. These are often called fundamental types, or primitives. The integer whole number types are short, int and long. The float, double, and long double types are floating point, or real number types. The char type holds a single character, and the bool type contains either a true or false value. In C++, the exact size and range of the data types are not fixed. Instead, they are dependent on the system for which the program is compiled. The sizes shown in this table are those found on most 32-bit systems, and are given in C++ bytes. A byte in C++ is the minimum addressable unit of memory, which is guaranteed to be at least 8 bits, but might also be 16 or 32 bits depending on the system. By definition, a char in C++ is 1 byte in size. Furthermore, the int type will have the same size as the processor's word size, so for a 32-bit system the integers will be 32 bits in size. Each integer type in the table must also be at least as large as the one preceding it. The same applies to floating point types, where each one must provide at least as much precision as the preceding one. To declare or create a variable, you start with the data type you want the variable to hold, followed by an identifier, which is the name of the variable. The name can consist of letters, numbers, and underscores, but it cannot start with a number. It also cannot contain spaces or special characters, and must not be a reserved keyword. To assign a value to a declared variable, the equal sign is used, which is called the assignment operator. The declaration and assignment can be combined into a single statement. When a variable is assigned a value, it then becomes defined. At the same time that the variable is declared, there is an alternative way of assigning it, by enclosing the value in parentheses. This is known as constructor initialization, and is equivalent to the previous statement. If you need to create more than one variable of the same type, there is a shorthand way of doing it using the comma operator. In addition to standard decimal notation, integers can also be assigned by using octal or hexadecimal notation, as seen here. Both numbers represent the same number, which in decimal notation is 50. Once a variable has been defined, meaning declared and assigned, you can use it by simply referencing the variable's name, for example to print it. Variables in C++ may be declared both globally and locally. A global variable is declared outside of any code blocks, and will be accessible from anywhere after it has been declared, even in other source files in the same project. A local variable, on the other hand, is declared inside of a function, and will only be accessible within that function, after it has been declared. The lifetime of a local variable is also limited. A global variable will remain allocated for the duration of the program, while a local variable will be destroyed when its function has finished executing. Global variables in C++ are automatically initialized to 0. Local variables, however, do not have this advantage. Instead, they will contain whatever garbage is left in that memory location. It is therefore a good idea to always give your local variables an initial value when they are declared. There are 4 integer types you can use, depending on how large a number you need the variable to hold. Many C++ compilers also support the long type, which is guaranteed to be at least 64 bits. This data type is included in the Microsoft C++ compiler. To determine the exact size of a data type, you can use the sizeOf operator. This operator returns the number of bytes that a data type occupies in the system you're compiling for. The Microsoft C++ compiler features an additional number of sized integer types. These types start with 2 underscores, followed by int, and the number of bits you want the integer to hold, either 8, 16, 32 or 64 bits. By default, all number types in the Microsoft C++ compiler are signed, and may therefore contain both positive and negative values. To explicitly declare a variable as signed, the signed keyword can be used. Conversely, if you only need to store positive values, you can declare integer types as unsigned to double their upper range. The signed and unsigned keywords may also be used as standalone types, which are short for unsigned and signed int. Similarly, the short and long data types are abbreviations of short int and long int. The floating point types can hold real numbers with different levels of precision. The precision shown here refers to the total number of digits in the number. For example, trying to assign more than 7 digits to a float means that the least significant digits will get rounded off. Floats and doubles can be assigned with exponential notation, in addition to decimal. The char type is commonly used to represent ASCII characters. The conversion between the number stored in the char and the character shown when the char is printed occurs automatically. For another integer type to be displayed as a character, it has to be explicitly cast to char. An explicit cast is performed by placing the desired data type in parentheses before the variable or constant to be converted. The bool type can store a Boolean value, which is a value that could only be either true or false. These values are specified with the true and false keywords.